Want to introduce the topic a bit for everyone. The industry has become very good at proving hardware can be compromised, right? I think that's no mystery to any of us, right? What we still have not solved is what operational reality looks afterward, right? Detection, attribution, remediation, recovery, especially at scale, right? Today we're going to walk through one compromise scenario from three perspectives. The builder who shipped the device, the assessor who found the implant, and the product security team that has to live with the consequences. We're not going to survey the threat landscape. One scenario, three chapters. We're going to be honest about where each chapter fails. Let's go. Quick show of hands here. How many people in this room believe their organization could reliably detect firmware-level persistence in deployed network infrastructure?
Yes. Look at that. Strong hands. Strong
hands.
Strong
so
hands.
we got some capable people. We know that, right? That's what we're here to talk about today. So let me set the scenario. We have an enterprise managed switch. It's deployed in 200 plus branch offices, right? We have a firmware level implant introduced in the supply chain, right? It survives OS reload, factory reset doesn't touch it. The organization doesn't know it's there, right? Every question today comes back to this device, right? So I'm going to start with you, James. Our switch shipped to 200 branch offices. As I said, firmware level persistence, hidden well, right? When you look at the scenario from the product security side, what is the single thing that tells you the defender had absolutely no visibility into what just happened?
So I almost want to react and figure out how this happened. So that's where my brain is going, because I would very much want to be diving into supply chain with my, what I focus on. I think having awareness as to how the defender, the way you described it, the defender is not going to be able to identify it anyway. But I think that's really the reality. But from a builder point of view, it would be when they're trying to triage it with us, being like, hey, like your device isn't working correctly, or it's causing us issues. Trying to figure out those anomalies is really what we'd be focused on. Is there's got to be some kind of signals or indicators around the device that we would be looking for. So it's
what happens when those signals take years to come about, right? Because we've had nation-state level attacks at times, right?
Very patient.
That were very patient, supply chain oriented, right?
Yeah.
Dormant for years, right? What's the cycle look like from your perspective?
Well, so I think if you have no idea it's happening, then you have no idea it's happening, right? That's the reality. Typically, I'm brought in, or my teams are brought in when we do identify something is happening, like whether the device is misbehaving, it's causing trouble. That's where we would then start tearing it apart. And I think, as it relates to patience of attackers, we really have to think about our design of the rest of the system that is being deployed within to really help us, right? So my perspective here would be, we built something had an issue, and that's novel, and maybe they were extremely patient. They put in the chips, and it's been there for 5 years. It's now the scope, and then what are we looking at to understand? Is it all the chips that those came from that provider? Is it something else?
So you have a considerable background in governance, right? Does governance play any role in assessing the supply chain up to this point?
Oh yeah, and our customers most customers are fairly mature at this point. So when it comes to hardware and assessing of it, extreme due diligence on the chips. The governments, are a little more black and white, whether EU or anywhere other country. Like we've got banned hardware chips, suppliers, vendors around the planet, and so it's easier with some governments. We can follow in the lines. But what's also nice is the government restrictions that happen on chips and suppliers that maybe I don't know why we're not supposed to use those vendors, but we're restricted, so we rotate out. It has required us to build products that have resilience. I mean, we could take out the CPUs and put a different chip in. I mean, we're working with the prongs to make sure we could fit a different one in. And this really came from 2020, but now we have architectures that allow us to be really nimble on the supply chain of the hardware of the chipsets, but also I don't make one thing for one region. Like, I'm going to make it for everybody, right? So if the massive intelligence around the planet says don't use this and do it this way, then all the boats are going to rise. So that's how we think about it. Is yes, there's benefits, but I mean I have some incredible customers that are really sharp on the hardware side.
Okay.
And they steer us.
Thank you. Marcus, James just described how the switch got into the field. Right? It's vulnerable. We can't do anything about it. From your position at Somerset Recon, when you show up to test the device that an organization is proud of, what is the most common thing you find that they never expect? And if Somerset Recon was brought in to assess the switch from PCB level up, how do you take one attack path and turn it into a repeatable testing workflow that an organization can actually act on, right? So 2 things, how would you approach it? How do you turn that into a workflow that you can convey to your customer and say, hey, Mr. Customer, if you have the ability to do this kind of testing that I'm doing, here's a workflow that it would impart to you.
Well, it does just by chance have experience auditing supply chain devices that program devices at scale, and we were able to identify many 0 days that would affect one of the most popular embedded devices. So do have experience with that. And one of the questions was, what are people most surprised at? And it's not necessarily the category of bug, like a buffer overflow or a glitching a chip. It's the effect you can cause. So, for example, we do a lot of OT, medical space, and others. When you can chain bugs together or use a single bug to cause potential harm to people or loss of life, I think that's when people's eyes perk up and they're like, oh wow, this becomes more real. Something in the physical world can happen because of these bugs that you discovered. And then to piggyback on the question you're asking, how do we make it repeatable? What are some good methodologies in the testing workflow? I do think you have to test the full stack and really have solid equipment and a solid team, as well as we have checklists of we're making sure we check this throughout the process. And I think that is an effective way of at least getting a baseline on various devices that people.
Do you find it useful or effective / efficient, if you will, to educate the builders of the hardware you assess? So the engineering team that put the thing together, would you impart to them a workflow saying, hey guys, we found this issue, right? Next time, how about cross the T's, dot the I's in this manner? At least we can, not have this particular issue before, make it interesting for Somerset Recon when they come around to the next audit, right?
I think education's a big part of it. And we come here every year to teach the medical device hacking and defense training. So if you are interested in learning that, feel free to check it out. I do think that we see a lot of product developers taking courses to educate themselves before they're starting to build the products and get them in the field. And when you educate them on certain levels of attacks, they'll, maybe they've never heard of decapping or glitching or these variety of techniques. And just knowing that and introducing that early on in the discussion can mitigate a lot of risks. Just supplying the right, or choosing the right chip can help mitigate a lot of these risks. So.
Understood. So software security has EDR, security, incident, event management, XDR. Hardware security has what exactly, and why doesn't the equivalent exist? So if we were back to our switch, which is sitting in 200 branch offices right now with a firmware implant, right? What signal would even exist? I think none at this point if we're setting it up right. So, and back to you. What's your take on equivalent for what exists in the software industry?
I think potentially there are runtime capabilities that can be used for this particular use case. And I think when you talk about software and hardware, like where is the real vector of the firmware? Like, is it the first party firmware that the switch manufacturer is developing, or is it a third party, maybe another chip that boots, it has its own, microcontroller, has its own, firmware process, right? And is it living in there, right? And then what's the blast radius, in terms of what is the impact of the units of these particular switches, and can we have access to, a compromised device so we can put it in our lab environment and see how it responds, right? And see how, the behavior, right? Especially if you have a emulated environment, right? With clients, et cetera, you can glean a lot of information and then, find out what the attack vector is, what's the root cause. Again, you sort of work on that process, but there are capabilities these days. I think it's not widespread across certain sectors of devices. Enterprise switches may or may not be there yet, but consumer probably not. But as you get in heavily regulated environments, these are becoming more and more employed and implemented. Still isn't an easy job. You still have to have a whole environment behind that, to understand what this data means, right? And groom that and maintain that for you to actually do a good
So are we to understand that at a particular level of device, the tools, the mechanisms exist sort of in parallel with what software has?
That's right.
Okay. We'll continue with you, Aaron. When a hardware finding lands in your PCERT, like from an external researcher, right?
Yep.
Or from your own red team, right? What is the first decision that you have to make, and what information are you almost never given?
The first information I look for is, hey, if it's a researcher, thank you. We want more researcher engagement. We want to find these bugs. We want to find these issues before they're exposed, from third parties, right? And so, help me understand your thought process and how you're pursuing this weakness, and is this weakness, right? From we work with vendors across the space, right? And so, is it part of our boot process, for this particular weakness, right? And if it is, like, let's work with our third-party vendor, right? They'll have their own PCERT process as well to understand impact. So we do an impact assessment, right? And understand what the exposure is from not only the technical perspective, but just the units. Is this a newer unit? Next generation? Did we mess up? We mess up. Everyone messes up, right? And the more eyes, the better, right? Which is why we're participating at Pwned, as an example, and we'll reward folks for finding issues, and we've had some good results so far, right? But I think being able to manage the dynamics between the researcher, right? Reward them for the effort. We have to do the context in terms of, hey, what the impact is to the business, to our customers, right? What can this actually do? And have they found other areas of opportunity that they haven't really found, they're not naming it, but we can see it, and we have maybe that understanding, right? Or it's already known, and we still work with them. We reward, as much as we can, right? And, you go through the whole, is this an issue that we need to work with our distributors? Are these on the line? Do we need to stop line? To stop the manufacturing line, right? And we start quantifying the impact from a business side.
So this brings up yet another question from my mind here. I think I would like to understand if there's some sort of a better triage process. Are all of these items getting the same level of attention from your group when they're submitted to you? Or do you do, the hospital-like, triage process? Say, this is, older product, not so well deployed or not so, widely deployed, right? Yeah. Doesn't seem like a big issue or something like that. Or is everything getting full attention? 3 doctors on the case, quote unquote, right? From
we have multiple layers of triage, right? And what's the front door in this case, right? Is it, I guess raise your hand. What would be the front door for you all if you're looking at a firmware issue? Is it a common serial interface, right? Is it, would you raise your hand if it's UART, right? That might be one of the first ones, right? And then next you're probably going through another area, JTAG, right? Probably, right? And we're looking at different, chips, memory chips, right? Storage chips, right? And so, do we have a wrong component, or did we, what iteration or revision of hardware is this, right? But we do have, our managed partners who help us triage. We have our our team, we have our teams and our PRP certs that we want to get triple checked, even, especially if we have something that is maybe a core issue for a particular product family. Switch impacts all switch, all hands on deck. Let's go. Let's do it. That is the number one, kind of platform that supplies connectivity to businesses, right? And you won't have that if you don't have a switch. You won't have your wireless that's supplying the conference as an example. So we take it very seriously. We have several iterations of triage.
James, you're dying to say something, and
It's just I love how you're framing it. So like when we first off, thank you for all the researchers.
Right.
Like, thank you. Like let us know what you find. When we look at it, I want to see proof of concept, right? Like, because I get a ton of that's a configuration issue, and it's literally on the manual. It's like you just hit the button, and you got to hit the other button, and it's locked. So I think one, thank you for the researchers. Two, we look for proof, and it's not that I'm challenging. It's just that I need to know that it actually works. Like what you found is real, and then for us, it's every issue is manned 100%. We bring the engineering team, the product teams that developed it. The security team works with them. Obviously, if we have evidence, but we're testing it anyway. We'll have things like, oh, this device is acting this way or this. We're we work very hard. Where did it come from? What factory? What warehouse? Who gave it to you? Right? Well, it was a salesperson that sent it this way, and you're like, all right, is that a test unit? What is this? Really try to understand the state of reality, and then just following.
It's like that book POC or GTFO, right?
Yeah.
Yep.
Well, we get a lot of hey, this doesn't do it this way, and you're like, I need something. Give me a bone to chew on so I can go follow that. And the proof of concept really helps. And some people will send code, some people will send a video. It's anything. Help me.
Yeah, and I think it really helps in the testing process to validate your defenses as well once you've made a mitigation.
But it also then I understand the firmware version. I understand what hardware it was on, and you're probably right.
Yeah.
I just can't figure it out when I have all these versions in my lab, and it's where did this originate from? And then is it something we built and we replicated out?
James, I'd like to interject here a bit and maybe flip the script if we could. And I would like to understand from you, if the tables are turned, now you uncover something, right? And you have to report it. From your perspective, what makes it over that proverbial wall? What do you throw over the wall?
What do we push out to fix for everybody?
No, what do you report? Let's say you engage with a third party, somebody created something for you that you put in your product.
Yep.
In your engineering, you uncover a potential bug, right?
Yeah.
Now you're on the other side of that equation. You have to report to that manufacturer that created that particular component,
Sure.
right? What do you throw over the wall to them and say, hey, here's what I found, and what does that look like?
Yeah, I think it's probably exactly as all the researchers here would do it, right? We have agreements where you're going to follow our SDLC, right? If you found something in their product, we expect them to fix it. If I find something, I expect them to fix it. And so usually it's very direct. It is, here's an issue, it causes this. We got a clock running.
How do you deal with issues where you can't fully disclose because this is a new product of yours, right? You have some conflict of interest in the disclosure process. How do you deal with that?
So, if you're referring to people that we trust, that helped us make that solution together, we're bounded together, right? It's still me, right? It can be all the vendors together, but it's still me on the box, right? And so we work as one, right? And do we have suppliers that don't always as fast as we want? Yeah. And then we have to come up with an up-level fix, right? Or we rotate it out. That's what the resilience is about.
Your comment, then I'm taking it that you're kind of taking the burden off the supply chain as well. Is that correct?
Yeah, we deeply work with it. It's our responsibility. We pick the chips, we pick the partners, we pick the boards, we pick I picked it all. Yeah. Right now, if I pick somebody that hasn't done it great, we look at our sourcing, what's the response rate, how they're doing. We look at indicators to make sure that they're good organizations, and sometimes they just they look great and they just don't execute great. And I have to move fast in those scenarios, right? Because I'm dealing with life safety, right?
Understood.
And we will stop ship. We'll do whatever we got to do to make it better.
Marcus, back to you. When you hand over findings to a product security team, what happens to it? And what would you need to see change in how teams receive and act on hardware security findings?
I think the vast majority of clients we've worked with are very responsive. There's a readout, go over the findings, and commonly most of them are implemented, especially the higher severity findings. I did have one unfortunate issue where we were doing a readout. We were paid by someone to test a third party, and during the third party discussion, they stopped the presentation and had us exit the physical building of the location. And it was because the head of product security got really angry and thought that they would potentially lose a lot of revenue on this new thing. And I think that what I'd like to see better is those small set of folks who do have that mentality. They're going to have bugs. If we take a look at your devices, or we're going to find stuff. Just be open to it, and then realize that it's a process and not just. And most of the time, the vendor procuring your things is not going to say, "I'm not going to buy that." They say, "Okay, well, let's see it mitigated, and now I have more trust in that product."
So a follow-up question with that, in your type of engagements where you are dealing with the baby, quote unquote, of a particular vendor, right, and you have to tread carefully, do you find yourself in the position to having to explain, to having to justify, to having to soothe egos at the same time? Is that something that falls within what you do?
I think it's a difficult balance when communicating, security vulnerabilities to a new product, and those that have spent countless hours building it, hard sweat and tears. And I do think you have to be delicate when you do communicate that to them. And it's not that you're bringing emotion to it; you're just conveying vulnerabilities technically. And I think that goes over a lot better than if you were to use hacker nomenclature or negative language when discussing their product or security vulnerabilities.
Got it. So Aaron, let's go back to you here and get back to our switch with the compromised firmware. Right? Walk us through what response to a confirmed hardware compromise actually looks like inside a product security team.
Just a quick comment. We love working with hackers, researchers like Marcus, and we sometimes leverage them for strategic opportunities where we may know there's some things that exist in a particular area of a device that we want double click on, or hey, let's say we're doing something risky as a business, sending these devices to a particular region, and we want to make sure we're thorough and rigorous in the device security and have that assurance, right? And so not only internally and within the groups at the company, but also externally, they're key partners for our success. So folks like Marcus, we love working with them and researchers, right? So, but in terms of like a confirmed compromise, we're talking about in a switch, and we're talking about a firmware-level type of
implant,
implant, right? And you're asking, what are the steps of the PCER process?
It
How do we
lands,
manage that?
You need to have at it right now. What do you do first?
Yeah, we touched on it a little bit initially. I think we need to understand, from the finder, the reporter, right? Is there, proof of concept? Is there a video? Can we replicate that?
Add a little bit here, and sorry for interjecting. Sure. I'm going to add a little bit here. What I want to get insight in is you are the team that covers the gap between the researcher and engineering, right? You cover the gap between finding and remediation, right? I want to understand how that works. Give us the best insight you can.
Well, there's a lot more parties than just engineering and security. You have legal, hardware, communications, all the fun groups, right? When there's something that could be potentially critically impacted, right? And so we're doing a lot of translating, right? We're replicating. We have our own pen testers, red teamers, right? If we don't understand it, there's a problem. We usually get to an agreed medium in terms of, this is, this particular, criticality, right? And then we work with our teams, engineering, and to scope out, okay, is this a software level fix or is this a hardware level fix, right? Those are two different discussions and they go two different ways, right? You have a hardware level fix. We're talking, and these are opportunities too for next generation or even for respins, right, of these particular, devices. Still millions, right, millions of dollars, right, and in the particular problem scope here. But in the software side, right, if we can fix it, maybe there's a manufacturing exposure, that maybe there's a model that particular device, to say a switch in this case, was using with our partners there. How do we fix this problem? Is it in the manufacturing line? Is it in our manufacturing golden image, right? We want to make sure customers are safe out of the box, right? And how fast can we get this out? And then where are the devices at? How many customers are running this device, right? How many are in the distribution, right? And how fast can we get this out? And then how can we work with the customers to get them upgraded? So, contacting them and all that.
Does that impact assessment dictate how you act?
Yes, to a degree. There's a technical impact assessment, right? And then there's the business aspect, right? The context there of where I will, ask my team, like, let's look at the devices that are here that are impacted. How long has this device been out? And is this code, from this particular firmware, is this firmware on just a switch? Is it on routers? Is it on other device types, right? There could be shared code bases or shared suppliers. Highly likely, right? And, we manage the active management of those fixes, and we have a tight timeline, of getting those fixes out, and working on disclosure, right? If customers need to act, we're putting out a disclosure. We're not going to leave them vulnerable or leave them exposed. That's a key aspect of trusting us to be able to supply your network securely, so you can communicate and do what you do, right? Vibe code what you need to vibe code.
Understood. James, same question for you. You get the report.
Yeah.
It's been reported. You need to remediate. Walk us through what happens in between.
Very similar. But I think, acting as a translation, when we get this research and this data, trying to make it, realistic, meaning like, bring it into the real world. Like, great, this can happen, but what is the impact to the humans that are using our products?
So what?
Like,
right?
yeah, it's because it makes it real life, right? Like, we're like, oh, this can happen. You're like, and? Right? Like, no, but if it's attached to this building or this system, then all that goes off. And you're like, okay, that's super bad, actually. And so, one, we really make sure we understand that, because everything is treated with such urgency, because there is so much life safety, that we are always just kind of full tilt to fix, and whatever engineering was working on, now they're working on this kind of thing. And so the actions are understand, is it life safety? Is it running through the factories right now? The scope on the suppliers is very important, because I need to know, do I need to stop the factory? Right? Should I just do a stop ship? Like, is it that kind of thing that it's going out the door, it's wrong? Like, and maybe it's an error at the factory, like, oh, the J tags or whatever, right? Like, maybe somebody had it, like, there was somebody that just does a human error at the factory, right? Like, so it's really understanding the flow of where it is, and because we're bringing the same intensity on all of them, and it's, all right, so do we need to stop what's going in the market? Do we need to do this instead? Or is it, no, we can actually fix those that are in flight and in market, so let's address it. And so that's really our responses go, because we're all about, we're engineers, like, we want to build the things, we want to fix the things, we want to make them right. And so, and if it's a supplier, right, that energy goes equally right there. Like, we will go to that supplier's factory and work with them, and we will correct it, right? It is 100% all hands on every one of them, which is,
Here comes the obvious question after all of this. Can you actually remediate hardware in the field, or is pull and replace the only
oh no, it's
real
very easy.
answer
We just
here?
roll trucks.
Yeah.
Don't worry.
Is that,
Like, that's the reality. I mean, it's hardware. Like,
yeah, in our scenario, we're talking about 200 branch offices, and what does the math look like?
Roll the trucks.
In your scenario. Yeah.
I'm telling you.
Trucks, that's it?
Well, it's just what we say, right? Like, it's a physical thing. How do you go fix a physical thing? You go to the physical thing. Yeah. If I can do it remotely, I'm super thrilled. But I mean, and that happens, and so that's why we work so intensely on, like, what you were describing, right? Like, these things that we have to think about, because they don't want to roll a truck. Like, you guys would be really upset if the AC turned off right now, right? But one of you guys found something, and we're going to go turn it off and turn it back on, right? Because we got, like, that's messy, right? Physical control systems, like you really notice. And so, but it's immediate, right? And we work with great partners that are all distributed integrators that deploy these technologies, and we all work together. And that's you fix it, right? And
Aaron, your take on this?
Yeah,
since you're
hardware's
closer to
forever,
this,
right?
yeah.
Hardware's forever, and so
Yeah.
we have to fix hardware with the new device, and we're getting that as fast as we can, and fixing the ones that have the issues. And these things have happened over the years, and they're extremely painful, and it's not something, and they're embarrassing, really. Frankly, these are things that I think most manufacturers have been around for a while. They've had some circumstance, whether it's code quality, certificate related, or security related, or adjacent, right? Yeah. These things have happened, right? And they probably will continue to happen.
Since in the past, we didn't know before.
Yes.
Like it was 40 years ago.
But I think the fragility of the systems, today are going to change by next year. I think we're going to move to a different state with how fast we're moving with, code development, agentic, right? If you think about where we're at, right?
It's still not going to change the hardware, right? The
Yes,
equation's
yes.
the same, right?
But maybe the, uploading, maybe a new FPGA firmware, right? Maybe we'll have some more confidence because we're maybe updating that more often than once or twice a year, or maybe a bootloader as an example. So these fragile systems that people don't want to touch because they have a high likelihood of maybe breaking a device, right? I think that confidence, that trust, will grow over time, and I think this is a good opportunity, this year, and I think we'll see that in the coming years.
Marcus, back to you here with another question from your position as an external tester. When you see an organization's incident response process for hardware, what do you think breaks there first? And at what point during a hardware compromise do you stop trusting the device from a specific manufacturer entirely? And once trust is gone, how do you ever regain it? And I would like your perspective as the attacker, so to speak. Right?
I think the first thing that breaks is detection. I've been in several circumstances where you can extract a key and passively monitor communication systems, or to be in on a camera system watching someone, listening with someone, and getting that realization that, oh wow, this embedded device, no one's probably ever going to know that I was on it during a red team assessment. And when you see that, you realize that embedded devices don't have the same types of detection and protection. But when we do get detected, I think that our methodology is, as an attacker, alter it and try to test the next go around, try to make sure that we don't get detected on the next go. There have been several places where we got burned, where the tamper got lifted and it zeroized the chip, and we're like, dang man, that was expensive. But that's the rare cases of folks doing it well.
And thank you for that. And Aaron and James, both of you, I'd like your take on this as well, because I think the companies you're representing, trust plays a crucial role, right? How do you engineer to retain the trust of your customers?
Wow.
How do you engineer hardware to retain the trust of your customers?
Well, do it right.
That's easy, James.
Well, I mean, you're asking
more
for
than
build
that.
trust, right? If I took care of you today, and I'm like, well, I mean, think from a researcher side, for how do you have trust with us? Like, we respect you, and we handle that directly, and like we really dive thoroughly into those findings. With how do we maintain trust with our customers? Is if something's wrong, then we reach out and we work with them directly. And I think the way you maintain trust, even if things go crazy and get real bad, is that you are always leaning in for the customer, right? And they understand, like things are hard, right? Technology gets a little crazy sometimes, right? And like how you react and how you help them and support them, that's how we maintain trust, right? Like just do the right thing, get them the fixes, meet them where they are, like
Own it, right?
own
Take
it.
ownership.
Don't dodge it. Be like, oh, that was a third. Again, that was a third party part. No. Like that's us.
Yep.
Like we're responsible.
Aaron,
Yeah,
your
it's
take.
part of our trust ecosystem. It's in our device. That's part. You trust us, with the device that you bought, right? So similar, like make it right, not make the device right, but like make it right with, the customer. Own it, be responsible. Have all the practices and internally to make sure that, hey, we talked about, whether it's a post-incident or a post-mortem, whatever you want to call it, right? What actually happened? What checks do we need to put in place? Is there something in our, maybe design? Is something in our review cycle? Is there something post, in a different iteration, right? Be able to share that. And then any other things that we can, offer in terms of, hey, we're engaging the community, right? We have a bounty, we have these different areas, right? And we're going to continue to do that. And if we mess up, we're going to continue to own that and make it right, and show you here's all the things we're doing, right? And work together.
Do you find that this approach minimizes the erosion of trust in general?
Well,
Because some folks, would say, well, you messed up once.
But you have to
I'm not
learn,
gonna put this.
right? I think we have a culture where you have to, if you find something, that lesson should get woven back into the pen tests and the quality checks and those things, right? Like, I know if I'm a customer and I get the same problem, the same error, year after year with that same product, I'm probably not. You're not learning.
Yeah.
So like we have to like evolve internally. So with every finding and every event and every piece, right, we need to update what we do. Like we just need to do better all across the organization.
Do you find, and this is for all of you, that in an audience such as this one, there's a lot more passes to be handed out, a lot more understanding because the audience understands how hard it is to mitigate against and remediate the problems that we've just talked about, right? Versus a regular customer, right?
In terms of like the attack, let's say like, oh, it's hardware, I have physical access to a hardware.
Let's just say a researcher would be much more compassionate towards the bridging the gap to remediation versus a regular customer that has invested in that infrastructure and says, I don't much care what you do, fix it.
Yep.
Right?
I mean, you're definitely internalizing that, right? And you're driving and you're pushing as fast as you can.
That's right. That sounds about right.
Like that's all you can do.
They paid for it to be secure and operating right. Like what you're describing is it's not, right? And so, you didn't match their energy, right?
Is hardware level detection fundamentally unsolvable or just underinvested? And what would actually change the answer? Marcus, you were first.
I would say underinvested so far. I think there's been a lot of work in the software security state of increasing, but I think if you think about the core of a lot of these vulnerabilities, it's a combination of data being interpreted as code or a mismanagement of that in hardware when you're reading from JTAG or you're altering an instruction. When that happens, you don't have a solid source of truth, and I think that you could have a lot of mitigations to help protect and separate that code and data while it's processing at the fundamental layers of hardware, and I think a lot of folks could benefit from that in the future.
So your lane is investment problem.
I would say that's one aspect.
One aspect of it. Would you err towards investment or structural problem if you were to pick one?
I would say both structurally, like a von Neumann architecture, and then the investment of improving
We gotta
it
pick
both.
one.
Oh, we got to pick one?
Yeah.
But it is an architecture, though.
Yeah.
Like
To each his own. This is why we're asking. Structural problem, investment problem.
I say structural one and investment two.
Two. Okay.
quantifying that investment is the biggest challenge. How are you, measuring the success of this particular hardware detection and what it's going to bring to customers and, the lifespan of that device? And is that a service you're going to offer, for a switch, right? And
I think what we're trying to find out here is it something that money can solve? We can throw more money at it. We know it brings benefits, right? Or is it something that is at broad scale not doable effectively?
everything's doable.
Okay. So money problem, right?
Money problem.
Okay. James.
Well, So, but I think it has to do with the ideas that I saw at the conference today, and there's detections we can do. Like I'm building systems now that are monitoring the vibrations and acoustics of hardware systems like HVACs to tell you if it needs a maintenance mode, right? Like I'm seeing things today where you guys are seeing like, oh, the pulse rate is varied here, or the temperature change, or like, so it's there. You have the anomalies, you have the signals that something has been misbehaving in it, and so I think that there is a potential to be bringing those ideas into that kind of solution. But it's also very hard because you become so far from that on the stack of when you're delivering those solutions, and hardware, it has to rise up into that I would say the organic meat of the organization is running it, and sometimes I think there's a little bit of obfuscation that's benefit. It's like, oh, like we always talk about apps now, and like there's an entire stack here. Like we gotta get that base.
If you were to take sort of a 10,000-foot view right now, James, and answer this question for us here, what should vendors be building into hardware today, not to make the current attacks harder, but rather to make future detection possible? Right? So what do you think they need to put in so they can detect better? Does that make sense?
Hypothetical vendor, obviously.
Yeah. And are these like isolated devices, not like connected, like cloud connected? Okay.
Yeah, I think
It's all client side, right?
Yeah.
we're trying to like zoom this in. Like, can we give me more? I would like we talk about post quantum encryption, and we're talking about a lot of this isolations, and so I would push to see more of system integrity across all the components and the interactive elements as something that we have seen some benefit, and I think, but that's a long problem to solve. And so I think if I had to pick one, I would pick that.
Okay. Aaron, care to comment?
I live in a world where we straddle both like on-prem and connected, network devices, IoT, right? So there are capabilities where we're maybe monitoring the hardware that we can maybe correlate to events. Let's say it's power, let's say it's fan, let's say these other areas that we can, for different reasons, right? Maybe that's part of what its function is, but and let's say we have a weakness in software that computes. Let's say it ticks off maybe a crypto engine. We'll be able to monitor that. And that's just, again, when you have a connected environment, you have benefits and telemetry that you can take advantage of. I mentioned on-prem, right? And kind of all client side, like, there's nothing you can trust on the client side. You can manipulate that. You can take advantage of that, right?
I like that it's all client side, yeah.
So that's my
Marcus, the truth from you, if we're being honest here, are most organizations operationally incapable of handling sophisticated hardware compromises today? We're not talking about the manufacturer side, but the end users of that technology. Are they operationally incapable to track down sophisticated hardware compromises?
I would say that in most cases that's probably true, and then in some cases definitely can invest it. I think right now there's a cost to incident response, and a cost to developing a capability to not be detected. So I think that those costs are an interesting cat and mouse game that we always play in security.
Is it a question of cost or capability?
I think if you're looking at hardware, you can eventually get down to the transistors and eventually get down to the source of truth. But some of that type of analysis is very expensive. So I would say, in most cases it is a cost.
Sometimes it doesn't make sense, right, for the device type.
And it's out of the realm of any organization. Okay, last question for each and every one of you. I want one sentence from each of you. The one thing I want this room to be doing differently starting Monday is?
Find things, share it, not up publicly, obviously.
Yeah.
Let us know so we can fix it together. And I think all the research I saw, I got two things, is share what should be done, right? Like I saw a lot of great presentations where we're talking about this or that, and it's like, I understand like what you can do with it, but like should that XYZ be done this way or that way, right? Like it's like put your recommendation in. That really helps. When there's so many configurations, there's so many opportunities of which sometimes it just takes a village to put it together. So yeah, share your recommendation.
Yeah.
Just reminds me of a lunch conversation. I know you said one sentence, but chatting with newer folks who are just getting into hardware security and just kind of reminiscing, 5-10 years ago, how difficult and how inaccessible, the ramp up was to get involved into hardware security and research, and how remarkable of an evolution we've gotten to, and we're still, climbing that, right? But I think keep building tools, right? Keep making, your methodologies accessible to more folks to be able to practice them, right? Your lab environments as well, that's half the battle, right? And just, continue sharing. And I think we'll evolve to like a more stronger, rigorous, right, in the hardware space than that we are in the software space in some areas, right? So I think there's still a lot more opportunity, but we've came a long way in a short period of time. So proud of that.
Thank you.
I can talk to some of the researchers in attacker perspective. I would say that if you see JTAG and UART turned off, there are many other plentiful techniques you can go beyond to attack the hardware. And I think, studying up on that and leveraging those more advanced capabilities can really bring out a lot of bugs, and the bugs are very plentiful. So just go back and try to find them for us.
Okay.
Can I plug a project that talks on some of these?
Please.
I'm so sorry. Some of these protocols, right? SPI and let's say I2C, these serial communications. I lead a project called IoT Security Testing Guide. And so we have these inner communications as part of the testing catalog. And we're looking for more folks to help out in different areas that maybe you're an expert in, right? Maybe the faster buses or any other areas, right? That might be opportunities. So open source project with OWASP, and would love, for you to even learn if you're not maybe an expert in some of these SPI and I2C, all these, acronyms, but we are working to help as well, kind of give back to the community with that project.
Thank you. And to each and every one of you, I think my closing statement would be that I think we've gone through this process right now, and I think we can all conclude that we are very good at breaking hardware. We are much less good at watching it, catching it, or recovering from it. And the loop, from my perspective, is not closed yet, but I hope it's a lot clearer where it breaks. You've heard from some notable voices in the hardware space. Thank you all.